Hello, IB Environmental students. Now we're doing another Your Turn example option on macroinvertebrates. This is probably only a good choice if you did a macroinvertebrates related field work. So this one is a little different than the practice or the soil pH because there's a lot of data that can be kind of unorganized. So I did a lot of the raw data tables so that you could really see information in a somewhat organized form. So for instance, we see a strong table title 1 here for raw data. This is number of macroinvertebrates sampling in riffles, location 1 at Hidden Oak Stream with tolerance level, tolerant, moderate, or sensitive for 5 trials. So that means that we have a benthic macroinvertebrate column here. Now I just call them species A through D. Now for you, I would highly recommend actually finding out their exact Latin scientific name, and you would have filled that part in there for your actual IA. Looking up the actual tolerance level based on the Soil and Water Conservation District labels or the EPA or USGS labels, and then your actual original counts. So let's say that in this riffle you had been able to do 5 different kind of scoops or trials where you collected, and because this one was tolerant, you happen to find a lot of it in each of the different trials. But for the moderate and the sensitive ones that you thought you would find, you didn't find that many. So because there's a lot of tables, what I've done here is I actually combined the raw and the process data a little bit together. I've just color coded them. So for instance, here we have averages right here, right? And this is the average, it says, for the species A in riffle 1. Right? I know that because it says I've averaged for this data point here, column C, row 7 through column G, row 7, and that's right here. All right? Same thing, this one is this whole row right there, this whole row right there, and this whole row right there. And this is the standard deviations here. So notice that the standard deviation for this set is 0. That's because there's no change. There's 0 the whole time. Here it's pretty low because it's 0 or 1. Here it's getting a little bit higher. I messed up, so I'm going to go Control Z to go back. It's a little bit higher here because there's a little bit higher variation. And here we have the most variation because we have some 1, some 2, some 3s, and that has the highest standard deviation. All right, if I click on standard deviation, it should show me very similar standard deviation calculation as previously. All right, and so the way I've organized this is that each of these different tables is a different riffle or a pool. So here's riffle 2. Same thing, 5 trials for riffle 2. Over here, riffle 3. 5 trials for riffle 3. Averages and standard deviations. And down below, table 4, we have pool 1. I did that for you. And then here in table 5 and 6, that's where I want you to do some stuff yourself now. Here's pool 2 and pool 3. I want you to practice actually getting that data there yourself. So let's see if you can do it. So here's for pool 2. Let's try to actually do the average calculations. So again, to do average calculations, I can click on this box, right? I can go to the function up here. I go equal sign. For here, I want to average this whole row. I can select it by dragging across. Oops, but guess what? Miss Clausen was silly. She forgot to actually type in what equation she's doing. So she's going to go back and delete and now actually type in an equation with the parentheses. Now she's going to highlight and it should work. End parentheses, and then she gets an average. Same thing over here, equal sign, type in average. I can also type it down here. It says, did you want to do averaging? I say yes, I would like to do averaging, please. Highlight the stuff I want to average. End parentheses, go. Now for each of these, it was always on row 15, N through R, on row 15, On row 14, N through R, so the N through R is always consistent, so it's following a pattern. I think I can do my ninja trick by clicking on that little blue square and dragging the plus symbol down, and it's going to do all the averaging calculations for me. If I'm nervous it didn't do it right, I can always check. Did it do it? Yes, it sure did. I'm going to try the standard deviation. You try it yourself. Equal sign standard deviation. That's what I want it to do. For standard deviation, remember I also do all the trials that I'm interested in. Now notice that for standard deviation, a crazy thing happened. It has a crazy amount of significant digits. Right? I don't want more than one decimal place. So I click this lower the decimal places, please symbol. Alright, at the top, I'm going to do it one more time. Standard deviation, type it down here. Please do standard deviation for this set. Again, way too many significant digits. Lower the significant digits, please. Now again, I don't want to have to recalculate that each time. I can drag that down. The nice thing about dragging it down, it also was like, oh, you only want one decimal place? Sure, we'll do that for you. Alright, and that's great. So now I only have one more left to do. I got to do averaging for the pool 3 it says over here. We're going to do it one more time. Averaging this whole row. That was easy. It looks like it's going to be 1. I want to do the same thing dragging down. Standard deviation. I want to do this whole row. In the parentheses. Drag it down. Really nice. I do not want all of those digits. Oops. Only one decimal place, please. Alright, and so then I finish. Now, if I scroll over and down, I know it's a lot of data we're playing around with here. We can see that Ms. Clausen here started a process data table for you, and so that you wouldn't lose your mind, I inserted a lot of this stuff. I want you to copy and paste over your averages that you just worked hard to calculate. So let's do that. So I can highlight this set of averages. I'm going to go edit, copy, scroll back over. Now here's the super hard part. You think you know how to paste, but we're going to actually do a special paste. We're going to only paste the values themselves. We don't want to paste the equations, because if we paste the equations, it'll start trying to average all of these things here. We only wanted to put the numbers down. We're going to go grab the numbers for averaging for the last pool here. Edit, copy. Edit, paste. Special. Values only, please. Alright, and that was the last two averages. We would also want to grab the last two rounds of standard deviation. Edit, copy. Please paste special. Oh my goodness, why? Get rid of all of those extra digits. Last but not least, we want to do the same thing for our last round of standard deviation. Edit. Oh, copy. It's a lot of work, I know. Edit. Paste special, values only. Get rid of all of those extra digits. Oops, too far. Okay, so now what we see is that for most of these, we only have about 0.5 as our standard deviation, which is kind of high given that we most of the time only had 1 or 2 different organisms every trial. So that's kind of a high standard deviation given what we found. But that kind of makes sense given that this is working with actual organisms and it can be difficult to actually find them in the stream, and there was a drought potentially. So the last thing we want to do is we want to actually do some graphing. Now the graphing on this is pretty wild. It's pretty hard. So what we're going to do is we're going to highlight our IV, which is the different riffles and the different pools, and we're going to highlight our different averages. We're not going to highlight, actually we're going to highlight the whole thing. Excuse me. Google Sheets is kind of smart in this case. It's going to ignore some of the stuff. but we're smarter than it. We are going to have to do a lot of fixing. Right, insert chart. All right, so it thinks we should use this kind of chart. What is a this kind of chart anyways, Google Sheets? So let's go check it out. It says, why don't you use a stacked column chart? That's kind of cool because what it does is it puts the different species here, D, C, A, and B. All right. It tells me were they tolerant or sensitive. That's kind of nice, right? And it then has the amounts, but they're kind of added up on top of each other for each riffle. I could see if I like a different type of bar graph better. I could just do a regular one, and it has each of them separated instead of stacked on top of each other. For this, I'm actually going to be cool with you picking either. We'll see the pros and cons of them when we get over to doing error bars, actually. So let's go back to stacked. All right, if for some reason we had extra things in our series, we can switch. We could switch rows and columns if things were actually messed up for our IV and DV. Remember, we don't like usually having the title right there. It's really overwhelming, so we'll delete it. And in customize, we in this time really need our legend because we have a lot of different species that we're interested in. We need to, under axis title, go to horizontal axis. Right now it says benthic macroinvertebrates, but actually that's our legend has that stuff. We actually need locations at hidden oaks. All right, riffles or pools. Now, some of you guys, it might make more sense if you actually combined and averaged all pool data and all riffle data and only had 2 different bars to compare. That is something to do, and then you would have averaged across more like 15 things instead of just 5 trials. Let's switch now the vertical axis. All right, so what were we doing here? This is actually the number of benthic macroinvertebrates, but because we did each riffle or pool separately, how many trials do we have? N equals 5 trials, and this is an average, right? N equals 5 trials. Now the uncertainty is kind of hard here because this is full organisms. You're probably pretty sure you saw them. So we instead are going to not do an uncertainty here. We will go under series, and trend lines don't make sense here. We can add data labels, but it's really kind of overwhelming, so we're not going to do that. And even error bars are kind of overwhelming when we have this as a stacked chart. All right, so for error bars here, this is where things get hard, and you're going to have to argue why you want to do the error bars you want to do. So it defaults to percent, and it defaults to 10%. I think that's kind of a lot. Usually when we think about how confident we are in something, we want to be at least 95% confident, which leaves about 5% error of unconfidence. So if you are going to pick a percentage, I would rather you at least go down to 5%. And we can now see the error bars right here, but they're still kind of hard to read. If we did a constant value, keep in mind that the values are like each 1, 2, or 3. So if we were to do a constant value, we would have to do something 0.5 or less, and even that's ginormous. So in this case, really percentage might be the best thing, and we would maybe go with 5%. All right, because maybe that deals with our uncertainty or unconfidence in the data collection techniques. All right, let's go back to data here, and let's compare this really fast with if we had switched back to this column. Now, this is kind of interesting because now we can see the error bars a little bit separately because they're not all on top of each other. You can pick if you like the regular column chart or the stacked column chart better, but either way, the last thing you would need to do is in Google Docs to copy and paste this over. For some reason it's re-added our title here, and actually a title would be something we would add at the bottom here in Google Sheets and in Google Docs using all the information that we had. And of course, because this thing is annoying, it accidentally deleted our our vertical axis, so we got to add that back later. All right, wonderful job, guys.